All right, so we're going to be talking about the bridge design pattern. So for the intent, what's the intention of the bridge design pattern? Well, the bridge pattern is a structural design pattern that decouples an abstraction from its implementation so that the two can vary independently. It allows the two parts to vary independently. This pattern is often used in situations where a class or a system should be independent from the ways it is implemented or represented. So basic idea is that the bridge pattern's intent is to just decouple an abstraction from its implementation. So I have a good picture that I found on the internet for that. Pull it up right now. So yeah, as you can see here, you have an abstraction and an implementation, and it's called the bridge pattern, well, because it creates like a bridge between the two. Okay, applicability. The bridge pattern is similar to the adapter pattern that we studied in class. The major difference between those two is their use cases and how they're applied. The adapter pattern is used when two incompatible interfaces must be unified. So the adapter pattern is a result of existing incompatibilities, whereas the bridge pattern is something we use when we actually need to separate the interface from its implementation. So but the interface we mean like the abstraction, the abstract class. By decoupling the abstraction and the implementation, the system is less prone to changes in one part affecting the other. And as you saw in this picture right here, this picture shows it right now, so that uh, as you can see, so we said the system is less prone to changes in one part affecting the other. So like in a regular monolithic system, like changes to the system can mess up the whole system. Whereas if you have abstraction and implementation alone, changes in the abstraction will not affect implementation and vice versa. And this pattern, the bridge pattern, also makes the system more easily testable, as we can easily swap the implementation out for testing purposes without affecting the client code. Additionally, it allows for a more flexible and reusable code base by allowing the same implementation to be used by multiple abstractions. So this is a general class diagram of the bridge pattern. So this is our abstraction. It's an abstract class. It has an object as an attribute of type implementation. It has some features that are going to be implemented by this class that's going to extend from the abstract class. And this is the actual implementation here. The implementation interface also has some methods in it, which are going to be implemented by probably multiple concrete implementations, as you can see here. So for the structure of the pattern, the bridge pattern it splits a large class or a set of closely related classes into two separate hierarchies, the abstraction and the implementation, as we talked about earlier, which are developed independently of each other. The abstraction provides high-level application logic, but it relies on the implementation object to perform the actual low-level work, as we're going to see in the class diagram coming up right now. Abstraction can only communicate with the implementation object via methods declared there, the methods we just talked about inside the implementation interface. And the implementation declares the interface that's common for all concrete implementations. Yeah, we're going to have one interface that's going to be implemented by probably multiple concrete implementations, and different concrete implementations implement the interface defined, and refined abstractions extend the abstraction class and provide variants of control logic. As we talked about, the abstraction, the actual abstraction is the basic program logic, the basic control logic of the program, and the interface, the implementation interface, is what implements that logic. So refined abstraction extend the abstraction class and provide variants of control logic. They also work with different implementations via the general implementation interface. And so this is our example class diagram. We have the shape, abstract class. This is going to be our abstraction, and it has as you can see, we have also the implementation interface drawing API. So the shape has as an attribute the drawing API object. It has a drawing API, an object of type of drawing API. And for the methods, we have the actual constructor, shape constructor. And as you can see, the constructor takes in a drawing API object, and it has a draw method to be able to draw the shape. And so here the abstraction shape is the logic of our application. So we know our application is going to be dealing with shapes, and we're extending from the abstract shape object. We have a circle, and the circle has x, y, radius. All of these are doubles, and it implements the draw method, and it has a similar constructor to the one in shape, except it has also xy radius, because this is a circle. So yeah, it's a circle. It's going to have a radius and then xy points. Okay, and for the implementation, the drawing API, this API actually does the low level work of the program. It implements the shape, it draws the circle, and I mean, it's a drawing API, so it should draw any shape. It should draw any shape. But here in this program, since this is a basic program, we're only going to be dealing with circles. So the interface is going to implement orange circles and blue circles. But this is the purpose of the design pattern. You can have only a shape, and you can have multiple classes extending from shape, like circle, triangle, rectangle, whatever you want, whatever shape you want. And the implementation, the drawing API, should be able to draw any type of those shapes. Okay, now the code, we're going to demonstrate it in IntelliJ IDE. Okay, so as you can see here, I've set it up because I'm using Java, so I'm using packages. Packages are a lot easier to show the pattern and how the structure of it. So we have the abstraction package. This is gonna contain our abstraction, our shape abstraction. This is the drawing API object, constructor, and draw method. And this circle class extends from the shape abstract class and implements the draw method, overrides it and implements it. Also has its own constructor where we set x, y, and radius, and we call the super constructor. We send that drawing API that we get in here to that. And in our implementation, we have the drawing API as an interface. Okay, it has this draw circle method, takes in x, y, and radius. We have blue circle and orange circle. Both implement the drawing API, override the draw circle method. This is just a basic program, so we're just printing that this is an orange circle with radius, and same thing here. This is our client, our main driver. Okay, so we're gonna create a circle object. So we declare shape circle is assigned to new circle and new circle object, and we set the proper attributes, 3, 5, 6, whatever numbers you can put in here. And then a new blue circle object. It could also be an orange circle object. And then we take that object that we just created, the circle object, and we call the draw method. So right now I sent in a blue, I created a new blue circle object and sent it. So as I run the program, it says blue circle at 3, 5 and radius 6. If I want, I can send in an orange circle object. Okay, change it up. Yeah, orange circle at 3, 5, radius 8. And that's basically it. That's the bridge pattern.